Okay, this is mixture problems, part 1. We just read through this first problem, which I will read again in a second. But with all of these problems, we're going to organize with a table that look basically like this. We have the starting amount, what we're adding, what we're looking for, amounts, parts, and totals. So if we go back into this problem, let me zoom in just a little bit. A chemist has 70 milliliters of a 50% methane solution. So under the starting amount, we're going to put 70 for 70 milliliters. Okay? And it's only part methane. Shh, we're recording right now. It's part methane. So 50% we're going to change to a decimal. That is 0.5. You just move the decimal over. You can do 0.50 if you want. But that's the part that we started with. So we have 70 milliliters. Half of it's methane, so we're using this 50% or 0.5 is to show that half of it's methane. Okay, and it wants to know how much, so we don't know how much we're going to add. We're going to put an X here. How much of an 80% solution must she add so that the final solution is 60% methane? So we don't know how much we're adding, so we're going to put X there, but we do know it's 80%, so we're going to put 0.8 right here. Just change that to a decimal. And we know that the final solution is 60% methane. So under the final part, we're going to put 0.6. Now, we're starting with 70 and we're adding some more. So under the final amount, we're just going to add the 70 and the X together because we don't know what X is. And we're going to call that 70 plus X. Okay? Okay? Just stay with me. It's going to be fine. So we started with 70. We're adding some, which means we're going to end up with 70 plus X. We're starting with 50% methane. We're adding some 80% methane. And it's going to settle out somewhere to end up be 60% methane, somewhere in the middle. So if we do the totals column, if we're starting with 70 milliliters and half of it's methane, half of 70, if I multiply these together, so we're multiplying these together, half of 70 is 35. That means 35 milliliters are methane and 35 is something else. So if you imagine that we have like this test tube thing, I can't draw, and it's full up to here, like half of it is methane, okay, and half of it is something else, probably water. So that's what we're looking at. So if the whole thing is 70 milliliters, we're just looking at, okay, so that means half of it is 35. 35 milliliters of that 70 is methane. All right? And then we're going to multiply across on all of these. So I'm going to take X times 0.8, which just gives me 0.8X. I know that was exciting for you. And then we're going to take 70 plus X times 0.6, and we're going to distribute. So I'm going to take 0.6 times 70. If you do that on your calculator, you get 42. And then I'm going to take 0.6 times X, which gives you 0.6X. So pretend that this is in parentheses and we're distributing this to both of them. So basically what we've done is we've gotten enough information that we can make not a system of equations, just an equation. And what we're going to do is we are going to use a couple of, actually just this last column. So this last column, if we take the information out of it, we know we're starting with 35 milliliters of methane. And we know that 80% of the stuff we're adding is methane. So plus 0.8X. And we know that we're ending up with this final amount down here, 42 plus 0.6X. And so all of this column is being used to make this equation. These top two lines become the left-hand side. This bottom line becomes the right-hand side. And then all we have to do is solve it. Okay? So I have X's on both sides. I have 0.8X here and 0.6X here. What should I do?
Minus. Get them on the same side.
Get them to the same side and minus 0.6 I heard. Both excellent suggestions. So let's take that away. Get rid of that. So we'll have 35 plus 0.2X equals 42. Now we're trying to get, we just have one x in the problem, we're trying to get it by itself, but I can't divide by 0.2 yet. What do I have to do first?
Minus 35.
Subtract the 35. Good. So subtract the 35 from both sides. We get 0.2x equals 7. I don't know why my brain couldn't do that math, but it was taking a second. And then what do we do? Divide by 0.2 to cancel this out. Divide this by 0.2. You can do that on your calculator, and you end up with 35. It may seem weird that we're dividing and getting a bigger number, but it's because we're dividing by, and we're dividing that 7 into a bunch of little 20% pieces. So x is 35, and so that is the amount that we are adding, and so that means we're going to add 35 milliliters. That's my answer. That's how much 80% solution that you add.
One of these were on the PSAT.
Ooh, I'll bet it was on the PSAT.
And I didn't know how to do it.
Yeah, and
Now I do.
on some of them, there are some tricks that you can look up, but this is how I organize it, and after you do a bunch of these, it will probably get faster. The PSAT, I think you don't have as many problems an hour as the ACT. I don't remember. I need to look. They just redid all of it last year. So, okay, so let's go ahead and look at example 2, which is very similar to example 1. We're going to get a couple under our belt before we change anything, because that was weird and it was different and it's new, something new, because we've been doing all these review problems, something new. Okay, a coffee mix is to be made that sells for $2.50 by mixing 2 types of coffee. So this coffee company, pretend it's Folgers, or what's another coffee company?
Starbucks?
Starbucks, maybe, because you can buy that. They may already have 2 different kinds of coffee they already make, but they want to blend it, and they want to sell it for a certain amount that they know people will buy, and so we're going to optimize that a little bit. Okay, so we know that that's going to sell for $2.50 by mixing the 2 types, so that's going to go in the final somewhere. The cafe has 40 milliliters of coffee that costs $3. How much of another coffee that costs $1.50 should be added to the cafe mix with the first? Cafe is just Spanish for coffee, so just go with it.
Actually, Spanish for brown.
That's true.
I know.
But it's like a brown drink. But if you go in and say, un café negro, por favor, they'll know you want a black coffee. So.
Or cafe con leche.
Or, yeah, our cafe con leche is coffee with milk. Okay, so this looks completely different because we're not in a chemistry lab. It's money instead of percents, but it's going to be basically the same setup. So in our first line, I'm going to make 1, 2, 3, 4 lines this way, and we're still going to have, I'll extend this out this way, we're still going to have what we start with, what we add, and the final, and I made too many lines. Oops. So pretend that's not there. I can't find my big eraser. I never can under pressure. Okay, and then at the top, we're going to make amount and part in total. So all the same information on how you set up the table. So we're starting with how much coffee?
No.
Not enough coffee. That's the
40
answer.
milliliters.
40 milliliters.
Oh, yeah, my bad.
And so this is probably like the mix. It's like they haven't actually brewed it yet. And it is $3. So instead of a percent, we're going to put our dollars in here. This is just going to be 3. It's what we're going to use for our parts. So instead of percents, it's dollars. It's going to work the same. Okay? And then we're going to add an unknown amount of coffee that sells for $1.50. So since we don't know how much we're adding, that's what we're looking for. We're going to call that X. And we know it's going to sell for $1.50. So we're going to put $1.50 there. Okay? We also know that when we mix them together, we want it to sell for $2.50. So on the final, we know that we're going to want it to sell for $2.50. So when we're figuring out the final amount, we had 40 milliliters and we're adding some unknown amounts. So what would go here?
40 plus X.
40 plus X. Very good. Same thing we did with the chemistry problem. That's just this one happens to be money. And then you're going to multiply everything across. So 40 times 3 is 120. X times $1.50 is just 150. X. If you want to make that 1.5x, you can. I just think with money it helps to have the little decimals. And then we're going to take this 250 and multiply it by both of these. So 250
Is 100.
times 40, is it 100? It is 100. Good job. 100 plus 2.50x, or 2.5x, however you want to do that. Sorry, my table is not perfect. I debated making the table and putting it on there, but then the table's not made for you on the homework, so I thought, well, we better practice. And I'm really sorry that I didn't get all this erased. Okay, but now we can use this last column to set up an equation. Let's see if you guys can help me do it. What would be the left side of my equation?
120
plus 1.5x.
1.5x equals
100 plus 2.5.
100 plus 2.5x. And so they took the zeros off of the $1.50 and 250, which is totally fine. So they're taking this and adding them together, and it's equal this. So the final is always on the other side of the equal sign. For this particular kind of problem, it will change a little. Okay, so I have 1.5x here, 2.5x here. We need to get all of it to the same side. What do you recommend?
minus 2.5.
Or minus 1.5. I like to subtract the 1.5 to keep it positive. You can totally subtract the 2.5 if you want to. We will get the same answer. You'll just have negatives. So over here, these cancel, and we get 120 equals 100 plus 2.5 minus 1.5 is just 1. So 1x. Now what? Good. Subtract 100. Good job. And so we get 20 equals, and I can take the 1 off that and just call it x. And so we're adding 20 milliliters of that $1.50 coffee. So we're figuring out how much of the cheap stuff to add to the expensive stuff to get something somewhere in between. And we'll probably put some sort of cute name on it so people will buy it. Because that's what they do. That's what they do. I don't go to Starbucks because I can't drink coffee. But
More expensive, cheap coffee.
yeah, more expensive, cheaper coffee. And then they might add some pumpkin spice to it and then, charge you even more. But they don't want to lose money. And so they're going to make sure that they already have figured out how to make money off of these two kinds of coffee. And so if they do it this way, they know that they'll make money off the final product without having to do all of that back work to figure out profits and stuff. They just use what they already knew about the first two types. Okay, are you guys ready for example 3? Yep, everybody here is. If you're watching the video, push pause if you need more time. Okay, example 3. A farmer has 2 types of milk. One that is 24% butterfat and another which is 18% butterfat. So this is getting into like your different kinds of milk. Although this doesn't, usually we have like whole milk and 2%, and this is probably coming from 2 different cows, and one of them just is a little bit more fatty. I don't know. So he has 24% and he's got 18%. Those are our 2 types. How much of each should he use to end up with 42 gallons of 20% butterfat? So it's somewhere in between, but it's not going to be half and half because 20 is not halfway between 18 and 24. So this is going to be set up in a similar but slightly different way. Okay, so we're still going to have the table. I'm going to try not to draw too many lines this time. 1, 2, 4 lines is all I need. And down the side, instead of start and add and final, since we're starting with 2 different kinds, we're going to call them milk 1 and milk 2. You could be more creative than that. And then final. Okay? So I did milk 1, milk 2, final. And then the top part stays the same. The amount, the part, and the total. All right, so we do not know how much of milk 1 or milk 2 we're going to use. It's asking how much of each should he use. And so we're going to need two variables. We're going to have X amount of milk 1 and Y amount of milk 2. And so we're setting that up. We do know the final amount, though, is 42 gallons. Okay? Then we know milk 1 is 24% butterfat. So that basically means it's 24% butterfat and 76% whatever else is in milk. Lots of water and calcium and whatever else is in it. Protein. But it's 24% fat. Milk starts off pretty fatty because it's for calves and it helps them grow. And we know that that milk 2 is 18%, so we're going to put 0.18 down here for that one. And we know that he wants to end up with 20%. So I'm going to put 0.20 down there. So I'm just changing the percents to decimals. You put a decimal in front of the percents. That's basically it. And then we can multiply this across. So x times 0.24 is 0.24x. Y times 0.18 is 0.18y. 42 times 0.2, if you do that on your calculator, is 8.4. We are going to get a system of equations on this. We're going to use this column to get our first equation. I'll write it that way. First equation, and we're going to use this column to get our second equation. And then we're going to have a system of equations, and that's because we have two unknowns, an x and a y. So my first equation, I'm just going to go down the list. It's going to be x plus y equals 42. We basically know that we're going to end up with 42 gallons if I add the first kind of milk and the second kind of milk together. That's what this says. First kind of milk plus the second kind of milk ends up with 42 gallons of the milk that we want. And then you can take this column over here and set up the second equation. So 0.24x plus 0.18y equals 8.4. Now, we haven't solved a lot of systems with decimals. There is a trick to get rid of the decimals. Do you just want to work with the decimals, or do you want to get rid of them?
Just work with them.
Just work with them? It doesn't bother you?
No.
So we can just work with them. If you wanted to get rid of them, you could take the second equation and multiply it by 100. And that would just move it back to just 24 and 18 and 840. But you can work with the decimals. It's actually going to save us a little bit of time to do it that way. So let's just eliminate the x's. Let's take this times negative 0.24. So that would give me negative 0.24x minus 0.24y equals whatever 0.24 times 42 is. And I haven't worked this one out, so let me try that. 0.24 times 42, it's going to be negative 10.08. Sorry, I'm off on my notebook paper there, but you can see it. And the second equation, I'm going to stay the same. I like to rewrite it and have it all up and down aligned just because my brain works better that way. So I'm going to just rewrite that right here. Some people will just write it down here and then go from there. So I eliminated the x's. Let's kill those, get rid of them. And then we'll add everything else. So negative 0.24y plus 0.18y is negative 0.06y. And then if I add the negative 10.08 plus 8.4, we get negative 1.68. And hopefully when we divide by negative 0.06, this is going to look a lot nicer. 28. So y is 28. So let's go back to our problem. Y was the amount of milk 2. And we were measuring that in gallons. So that's 28 gallons of the second kind of milk, which is the 18% milk. We're used to 2% milk in the grocery store. This is 18% milk. It probably tastes a whole lot better. A friend of mine grew up on a dairy, and we used to get milk from them, and it does taste especially yummy to put in your hot chocolate and make. You just like melt chocolate in the milk. It's great. Just trust me on that.
I trust you.
Okay, and we knew that the total was going to be 42. So if we take this first equation, the x plus y equals 42, it's basically x plus 28 equals 42. Or you could just go back to common sense. We knew that the total was 42 and you could just subtract, because that's basically what will happen here. So you're going to subtract the 28 for the second kind of milk from the 42, and we end up with 14 gallons of the 24% milk. Some pretty fatty milk, but it probably tastes good. Kind of stuff you want to make caramels and chocolate and stuff out of. Okay, so we're not going to get through all of this in one set. Let's stop right there.